Okay, so the next topic is weighted graphs. Weighted graph for weighted graph by using adjacency matrix. Weighted graph representation by using adjacency matrix. So first types of graph is weighted undirected graphs. So since you are familiar with directed and undirected graphs, weighted just simply mean we are representing some specific value in between our edges. So each node has some integer representing the edge weight or edge priority. Then such a graph is considered as weighted graphs. So like in this graphical notation, those are the weights. 10, 3 and 5 are the weights. So when we are representing this graph, this weighted undirected graph by using adjacency matrix, only thing we have to do is representing our weight like this. Before we represent our edge like this, as you remember, only using 1 because we only needed to represented that edges exist or not. But when it comes to weighted unweighted graph, we also have to represent their existence and as well as their weight. So that's why we are using this type of method to represent a weighted graphs. And that's about undirected weighted graphs. So now we can move to implementation. So again, that is exact same thing that we have done before. Only difference you have to make is to make another line in order to represent it as a undirected graph. Then instead of representing its weight as 1, you have to specify it as a variable. So I'll just edit this function because display function and initializing function is exact same. So we can define another add edge function like u, v, and their specific weight. So adjacency matrix u and v must contain this weight. Since it is undirected, similarly u and v and u is also represented the same weight. And in here now we can represent specify our weights as well. So according to this example, 2 to 1 or 1 to 2 exact same thing has contained the weight of 10. Then 3 to 1 contains, or 1 to 3, it contains 5. Then 3 to 2 or 2 to 3 contains 3. Then we can compile and execute. Okay, so this is our adjacency matrix. 10 is over there, 5 is over there, and 3 is over there. So likewise, since it's undirected, this matrix is symmetric. So all the values derived from the main diagonal are exact same. So this is how we represent a weighted undirected graph by using C++ programming. So if you are not familiar with these display function or either initializing matrix functions, you can watch the very first video. In there I explained all of this stuff, and here I didn't explain it completely because it is the exact same code. Only here I explained it is add edge function, right? Because it is the only difference when it comes to undirected weighted graphs. Okay, so that is the so those are the everything I have to show about undirected weighted graphs. So thank you.